This lesson, we are learning or revising about parallel and perpendicular lines. Now, before we go into this lesson, you must have a good knowledge about chapter 5.15, which is about equation of straight lines, or 5.14, the gradient of straight lines. Okay, if you aren't good with them, you must go through them first. Okay, so the learning objective today is to understand the properties of parallel and perpendicular lines. We're going to learn how to determine the equations of parallel lines and the perpendicular lines. Then last, we're going to solve some problems that involve parallel and perpendicular lines, the properties of them. Okay, so before we start, have a go at the starter, pause the video, have a go. When you're ready for the answer, you can press play. Here are the answers for the starter. For y equals mx plus c, m refers to the gradient. Okay, m refers to the gradient. X and y represent the coordinates, and c represent the y-intercept. Question 2, the equation of a line is y equals mx plus c. We know m is a gradient, so y equals negative 2x plus c plus a gradient 5. Question 3, you have to first work out the gradient using y minus y1, y2 minus y1 over x2 minus x1. You get 2, sub in the 0.13. If you prefer to sub in the 0.37, it will also work. You should get the c equals 1 regardless. And therefore your answer will be y equals 2x plus 1. Now, if you need more practice on this, as I said, we went through all of this in chapter 5.14 and 5.15. Okay, do a bit of revision on that one if you need help on this. Okay. So first of all, we do a bit of recap on the equation of straight line. Actually, I'll skip that because this is all about 5.15. If you know how to do the starter questions, you should understand what's going on in here. Just a bit of a quick recap. You can read it yourself. Next, so parallel lines and perpendicular lines. So think about like dance moves, okay, with your friends. If you are, if both you and your friends are parallel lines, that means your dance move, you are dancing the same dance moves. Okay, so you're dancing the same moves, you are in sync. You know, you feel like you are the greatest partner in real life that you're gonna go on to take part in some competition together. I'm just kidding. So parallel lines. So that means all your actions, all your moves are in sync. Now, perpendicular lines are where, let's say, one is doing moonwalk, so you walk in parallel. Okay, the other one is doing, like, let's say, break dance. Then your dance moves will be completely right angle to each other because one is moving along a line and the other is doing some, I don't know what the names of those moves, like head turn, or like, those ones you got the head on the floor just rotating like a spinner, you know. So anyway, so that's the difference between parallel lines and perpendicular lines. So parallel lines have the same gradient. Gradient measure the steepness of a curve or graph. These two lines have the same steepness, then obviously they have the same gradient. Whereas if one is perpendicular to the other, the gradient will be a negative reciprocal of each other. So what does reciprocal means again? Reciprocal means you flip the fraction. So let's say 7. The reciprocal of 7, if you put a 7 over 1, it'll be 1 over 7. So this is called reciprocal. Okay, so reciprocal of each other. Okay, so 1/7 is also reciprocal of 7. Negative reciprocal, it means you put a negative, so 7 over 1 to negative 1 over 7. The negative means negative reciprocal. Okay, so negative reciprocal. So the equation will be a different gradient, it will be a different y-intercept. So whereas parallel lines, you have the same gradient, a different y-intercept. Example, determine if the following equations are parallel, perpendicular, or none. So to determine if they're parallel or perpendicular, the main thing that separates the two is about the gradient. So in other words, we have to work out the gradient. In a y equals mx plus c, the coefficient in front of x represents the gradient. So we have to take out the gradient of each line. Okay, so I'm just call it L1 and L2. So line 1 and line 2. Okay, so the L1, okay, the gradient equals 4 because y equals mx plus c. So that's the gradient. Okay, and for L2, the gradient is negative a quarter. You take the whole number in front of x. Okay, so what you do is you will then say so the question to you is, are they parallel then? Obviously not, because the gradient is not the same. But are they a negative reciprocal of the other? Yes, they are. Because if you do 4 for 1, 4 for 1, flip the fraction, put a negative, that's negative a quarter. So you say because, okay, the gradient of L2 is a negative reciprocal of L1, they are perpendicular to each other. Okay, right, so however, you do have to write down the gradient of each line specifically. All right, here comes practice question 1. Okay, determine if the following pairs of equations are parallel, perpendicular, or none. So pause the video, have a go at a question A, B, and C. Whenever you're ready for the answer, you can press play. Here are the answers. Now, question 1, a fairly straightforward one. You can compare gradient. They are parallel because they have the same gradient. They're 2. For question B, the first equation, the gradient is 3, which is quite easy to see. But for question 2, sorry, not question 2, sorry. The equation 2 or the line 2, you have to first of all make y the subject by removing 3x to the right hand side becomes negative 3x. Therefore, the gradient is negative 3. So I did give you a hint in here. You have to make y the subject first. So here you did. So here we do. So m is negative 3. So you would say they're neither parallel or perpendicular because the gradients, first of all, are not equal. One is 3, one is negative 3. And they're not negative reciprocal of the other. If this is negative a third, then that will be fine. Or this is a positive a third, then this will be fine. But because the fact that they are not negative reciprocal of the other, so they are not parallel, nor perpendicular. For C, now you have to make one a subject for both equation. The first one, you could divide both sides by 4. So y equals negative x over 4 plus a quarter. And then you should get the gradient as negative a quarter. So negative a quarter. But for line 2, you have to multiply both sides by 4. So it'll be y equals 4x minus 12. The gradient is 4. So in here, they are perpendicular to each other because 4 is a negative reciprocal to minus a quarter. Testing. Testing. Example, we have to write down an equation to a line that is parallel to y equals 2x plus 3. So a line that is parallel to this equation, now if they are parallel, means they have the same gradient but different y-intercept. So our task is quite simple for question 1. Same gradient, the gradient is 2. That means we need to do y equals 2x because it has to be 2x at different y-intercept. So you can choose any number that you like. Minus 1, y equals 2x plus 7. If you want to be a bit cheeky, you can say y equals 2x plus a million or something. I can't, how many zeros? Yeah, million, this million, etc. So anyway, as long as you have the same gradient, that's fine. Okay, so these lines are all parallel to y equals 2x plus 3. Question 2. Write a line that is perpendicular to y equals 2x plus 3. So we know the gradient here is 2. Therefore, the line that is perpendicular to it will have to be a negative reciprocal to 2, which is negative a half. Okay, so negative a half. So therefore, the equation will be y equals negative a half x plus anything that you like, plus 1, plus 3, plus 4, plus 5, plus 6, etc. Okay, so yeah, the main thing is the perpendicular, the gradient has to be negative reciprocal to the question. Question 3. Run an equation to a line that is parallel to 2x plus 3y equals 5. Now, can you tell me what is the first thing you have to do for this equation? Hopefully your answer is to tell me you have to first of all make y the subject. So you have to make y the subject first. Because you have to make y the subject to see what is the gradient. So 2x plus 3y, let me copy the question again. 2x plus 3y equals 5. To make y the subject, I'm going to move 2x to the right hand side. So 3y equals 5 minus 2x. Divided by 3, so y equals 5 over 3 minus 2 over 3x. Now you can write 5 minus 2x over 3, but I tend to prefer to split the 3 out. That's because I can clearly tell the gradient now is negative 2/3. So if they're parallel, parallel means the gradient will be the same thing, minus 2/3. So I just need to make y equals minus 2/3 of x plus anything that you like, plus 1, for example. Okay, and that will be the answer. Practice question 2. write down an equation of a line that is parallel to this, perpendicular to that, and perpendicular to that. Have a go at the question. When you're ready for the answer, you can press play. Question 1. Okay, so parallel means same gradient, so y equals minus 2x plus any number. Box means any number apart from 5, obviously. So any number, you can put -7 in there if you want to, negative, positive number, any number, or even a fraction if you prefer. Question 2 is perpendicular, so negative reciprocal to 3 is minus a third. So y equals minus a third x plus, again, your choice, any number. Okay, we're quite flexible in here. We're like the parents that could let the child do anything they want on the bus. Question 3. First of all, you have to make y the subject, so bring the x over, becomes 7 plus x, divide by 4 on both sides. The gradient for this equation is a quarter. So the gradient that is perpendicular to it will be -4. Because the negative reciprocal, flip the fraction, put a negative, it will be -4. So y equals minus 4x plus something that you like. Okay? Next, we're going to crank up a notch. So what we've done is we've learned how to distinguish between parallel and perpendicular lines. And we've learned also how to write a new equation that is parallel or perpendicular to the original. Now, but this time we're going to add another limitation here. We're going to add another limitation, which is to make it harder. We say this line parallel to this original line, we're passing through a particular point. Okay, so we need to use y equals mx plus c to help us. Now this was sort of the hardest in the parallel and perpendicular lines because we're combining everything you've learned before and everything you've learned about parallel and perpendicular lines. So find the equation for line parallel to y equal 2x plus 3, passing through the point minus 3, 2. First of all, we know the equation, this y equals 2x plus 3, has a gradient of 2. Now, the line that is parallel to it will also have the same gradient. So in the y equals mx plus c, we know the 2 could be put in here directly because they're parallel. So y equal 2x plus c. Next, we need to sub in the point minus 3, 2. So I'm going to different color. So we're going to sub in the point sub minus 3, 2. That's x and that's y. So we're going to sub it in. So y is 2, so 2 equal 2x, 2 times -3 plus c. 2 times minus 3 is -6. So 2 equals -6 plus c. Bring the minus 6 to the left hand side, becomes a plus. Then c equals 8. Okay, so if c equals 8, it means the equation is y equal 2x plus 8. And that's the answer. So y equals 2x plus 8. Part B. Let's try this one. Same thing. Y equals minus 3x plus 5. Now we know the gradient here is minus 3. But because the word perpendicular, it means it will be negative reciprocal for the gradient in our new equation. So y equals mx plus c. This time the gradient will be a third x plus c because it's perpendicular. So the negative reciprocal will be 1/3. Okay, so minus 3 over 1, flip it, 1 over minus 3, put a negative 1/3. Okay, next sub in the 0.6 minus 1, so sub 6. So we're going to substitute 6 minus 1. X is 6, y is minus 1. So minus 1 equal a third times 6 plus c. Minus 1 equals a third times 6, which is 2 plus c. So bring a 2 over, becomes minus, so minus 3 equals c. C equals minus 3. So the equation therefore is y equal a third x minus 3. And that will be the answer. Okay, y equals a third x minus 3. Testing. Here comes practice question 3. Okay, 4 questions. Be careful if you are asked about perpendicular or parallel to the original equation. So pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. So question A is perpendicular. So original gradient is 4. Perpendicular will be -1/4. So y equals minus 1/4 x plus c. Sub in the 0.43, you get c equals 4. So when c equals 4, y equals minus 1/4 x plus 4. Question B is parallel, so the gradient stay the same. Gradient is -1, so y equals minus x plus c. Sub in the 0.64, So you get c equals positive 10, so y equals negative x plus 10. For c, parallel again, the gradient will be the same, so it'll be a half. So a half x plus c, sub in the point minus 4, 7. So 7 equals a half times negative 4 plus c, etc. So work it out, c equals 9, so y equals a half x plus 9. Now for d, slightly trickier. The gradient in here is negative 5 over 4. Perpendicular means negative reciprocal. Flip the fraction, 4/5, cancel out the minus, which is just positive. So y equals 4/5 x plus c. Sub in the point 10 minus 1. So in here, 10 divided by 5 is 2. 2 times 4 is 8. So you get c equals negative 9. So, so the answer would be, so the answer would be y equals 4/5 of x minus 9. My mistake. Okay, so, and that's the answer.